We've gone through the various components about the building envelope, the whole construction, air sealing, insulation. Now the importance is testing.
Correct. Here we have a test mock-up house that we're going to be testing, and we basically show exactly how to run a test. And then, with this building being built the way a typical building is going to be, we've got can lights that are going to potentially have air leakage. Skylights will have air leakage locations. We've got basically a scuttle hole that has locations that might air leak. And as you see, we have windows everywhere around this building. Inside this house, we have every situation imaginable that we're able to basically test and then show where the locations are.
Okay, and so what becomes part of the test? What are the factors in this or equipment that would be used?
Well, I'd use a blower door. The blower doors are a big one. Our energy codes are requiring us to be a certain air leakage rate and under. And nowadays, with the buildings getting tighter and tighter with the energy codes, we have to verify that it's leaking. Right now, the air is leaking out of this building, but we don't know where. Sure. So what we do is something like this, where we have a blower door situated in an exterior opening. And what we're able to do is basically install it in an exterior opening. We have a fan that we're able to pressurize or depressurize the building. And then we have a calibrated manometer, another tool that's able to tell us what our air leakage rates are. This being a small house, we can use a single blower door. We can use a single fan. Larger commercial buildings, what we'll have is 3 basically fans in multiple doors, so we can create the pressure difference that's required in order to get an accurate level of air leakage, the rates that we are looking for.
Okay, and this is something that's pretty much being mandated by most municipalities and things like that for any type of new construction.
Correct. The energy codes are getting more strict, and they're mandating us test the facilities. Once we test the facilities, we have to do a simple calculation to tell us how much air is leaking out of the building or into the building, and we have to meet that in order to get basically the final approval from them to get occupancy.
And it benefits the end user. That way they know they have a building that's really performing the way it was designed to be.
Absolutely. We have a building that's going to be more energy efficient because it's not going to be leaking the conditioned air out of the envelope. They're paying to heat up the building, that heat should stay in the building. They're paying to cool down the building, that building should stay cool throughout the entire cycle, just because the air leakage is stopped and we have it thermally insulated correctly.
Okay. Now I see you pretty much have all the components in place. Is this something we can see actually activated?
Absolutely. We can run the test here, and we'll show some of the tools that we use. When we have this running, again, where's the air leakage coming from? Where's the air leaking out of? We have a smoke stick that we can use. We have an infrared camera that we're able to use. The smoke stick or a theatrical smoke generator, we can actually pressurize or depressurize the building and walk around and see where the air is coming from. Our infrared camera, when I have this running, this is actually creating like a 20-mile-an-hour wind on all sides of the building. People typically know exactly where the wind is coming from. Wind's blowing from the west. They can feel it on that side of the wall. But where's it leaking out of? This shows us the entire building. And with that air, say it's colder outside, it's going to pull in that cold air. It's going to cool down our building components. Infrared camera is going to show us that by showing us where the components are colder than the rest of the area.
Okay. Now, is this something you just kind of start out? Is there a time frame for this that it has to run?
No, we basically have to calibrate it. We have it all set up, situated. We turn it on, and once we turn on the fan, we basically are going to get our numbers pretty much instantaneous.
Okay. Is this something we could get started?
Let's do it. All right, Bruce, now we have the building depressurized, and we can't see it, but we have tools such as the smoke stick, where with the smoke stick, we're able to basically kind of give it a little puff, and if there's no air movement, it's going to just kind of linger.
Sure.
But if we put it somewhere where there might be a leakage, it's going to blow it away. So if you put your hand under here, you can actually kind of feel the cold air coming in.
Right, right.
So that's what we're able to do when we depressurize the building. We're able to go around with our smoke stick or a theatrical smoke and place it in the different locations where we're going to find leakage that we may not have expected it. Another useful tool is what's called the infrared camera. So our infrared camera is basically picks up the infrared heat that we can't see. So with us depressurizing the building, it's sucking that outside air in. As long as there's a temperature difference, it's going to start heating up or cooling down our building products. So what it does is it picks up our thermal imprint of basically what's going on. I just took the my hand off that wall and it's showing up my hand. It's showing the heat that's basically resonating from our drywall.
Right.
So with our blower door running and it pulling in that exterior air, it's going to warm up or cool down our building materials. Then I'm able to go around and actually check the entire building. This is going to save a lot of time doing destructive testing on trying to find out where that air is actually leaking from.
Basically, you're able to pinpoint the locations rather than open a larger area that might necessarily need to be.
Correct, correct. We're going to basically find exactly where that air is leaking from with the use of our smoke or infrared, rather than basically destroying some parts of our building to hopefully we find it, do a bunch of patches and it's destructive. Here we're able to pinpoint it a little bit better and we're able to narrow down our search. Our blower door, was going to be put on prior to the drywall being put on, the finishes. We're going to test our building to make sure that it's going to meet the requirements mandated by code. We're going to go around with our smoke and our infrared camera. We're going to find those situations. We're going to air seal it. They're going to put on their finishes so that when they come to do their final blower door test, it's going to meet the codes.
Okay, so it's a multi-step process. So it's not just something necessarily you do at the end. This is done during the phases of construction.
Correct. Once we have the finishes on there, now we're talking about destructive. And then we're going to have to really narrow it down. If I don't meet my numbers, I'm going to have to start tearing apart my building and using a lot of caulk and just trying to find little holes where I might find a big hole with my smoke or infrared camera.
Sure. But basically at the end, it's creating a tight environment and envelope for the building structure.
Right. We're making an airtight building where, again, that homeowner, that building owner is going to heat up the conditioned air inside here and it's going to stay. It's going to be a more energy efficient building for basically the end user.
And that's really what the importance is here.
Absolutely.
Okay. Appreciate the time.